Services compensation rates and applied those to the number of victims in each of the different crime categories. What we can tell you is that we really only had a decade of good, solid data that we could rely on, and anything that you see sort of prior to 1998 has been backcasted, and so clearly one of our recommendations is the availability of more data. One of the things that we also made note of in our study is that since 1995, Iceland has been offering offenders with offenses that carry a sentence of less than 6 months the option to do public service. And so we thought that that public service and community service actually should be added back in. So when we did our victimization costs, we took the number of people that were actually doing community service, the median time that was served that way, and multiplied it by the average minimum wage. And we added that back in because we saw that as a benefit to the community. Our preliminary recommendations after going through this would be that right now would be a good time to capture what the current spending is by the government on public justice, because if Iceland really is the leader, and it was identified by a group called, it was called Global Humanity in 2008, they were you were ranked number 1 amongst 144 countries for being the safest place in the world to live. So we felt that if you catch the baseline now for what you're spending in the government, any changes, and tracking that against changes in crime going up, should then be deducted. It also would be really valuable to do victim surveys. Capture the costs from the victim's perspective. What are they spending in medical costs and any psychological services, any absenteeism issues that are arising due to crime. We also felt that we had a lot of difficulty getting information. The health authority doesn't seem to have any information on victims' length of time in the hospital or the costs or anything like that. So there's an opportunity for the health authority to start gathering some more information. So that is a brief summary of recommendations on crime.
I'm going to move ahead to talk a little bit about household pollution abatement. So household pollution abatement is a defense expenditure cost to a household or society from increased industrialization or economic activity. In the case of the household, households use various ways to abate pollution. Using equipment or services such as air and water filters, or wastewater management such as sewage or septic. So GDP counts these things as benefits, GPI subtracts them as cost, as these things do not increase well-being, but merely restore environmental quality resulting from pollution externalities. So in our combination, I used 3 different indicators. The first was automobile emissions pollution, and that was added to sewage and septic cost per household. That was added to the solid waste per household for every unit. Those equal in total the household pollution abatement. The Environmental Agency of Iceland estimates that there's somewhere between 15,000 and 20,000 septic systems, primarily in rural areas. That was from 2008 value. So that's one of the only values that we don't have trended back into history. So it would be great if the local municipalities could be able to collect the information on the amount of septic systems, and we could kind of agglomerate that through the Union of Municipalities to find a central source for what the amount of septic and sewer. There's good data on the amount of people. 68% are on sewer in the area of Reykjavik, and then we multiplied that by a percent that Reykjavik Energy charges per liter of wastewater. So we have that information. We also have the amount of cost per bin for charging for solid waste, so that kind of information would be helpful to continue to collect on the amount of actual cost per household for waste in other cities besides Reykjavik. But considering 2/3 of the population is located in this area and on sewer, that we thought that was a good estimate for the broader cost of solid waste in society. So those final things, and then final recommendation would be directed towards the Transportation Directorate about the cost of catalytic converters. Is how we estimated automobile pollution, so to look at the amount of vehicles on the road and the cost of catalytic converters and annual emissions testing. We were able to find a general cost for catalytic converters, but annual emissions cost and air filters would be additional information that needed to be collected.
So for the resource depletion category, we considered these 5 resources in the depletion or addition: wetlands, the net gain of forests through afforestation campaigns, the costs of soil erosion, the depletion of non-renewable energy resources, and the depletion of fishery stocks. And I'm going to talk about the net loss of wetlands because that was the category we had the best data on. And so we know that wetlands are important for the ecosystem services they provide, such as habitat, cycling of nutrients and water. But in the 1940s, large-scale draining efforts were begun, funded by the government. So there is good data that exists on the kilometers that were dug of ditches so that wetlands could be used for agricultural purposes, mostly grazing lands. The peak of draining occurred in the 1960s and continued up until the 1990s. So you can see this graph is a cumulative loss of wetlands, and you can see it flattens out after the 1990s, and it actually goes down a little bit because in 1994 some of those ditches were begun to be filled in, restoring the wetlands. But as you can see, that's been a very small percentage of the ditches that were dug in the first place. So in calculating the worth of these wetlands that were lost, we used Hliner Oskarsson's estimate that 7.3 kilometers of ditches dug would be the equivalent of the draining of 1 square kilometer of wetlands. And then we evaluated each of those square kilometers of wetlands as being worth a fixed rate that we determined from previous measures of what wetlands were worth. Our recommendations for the resource depletion category was that better data collection needed to take place so that trends such as this, for which we had good data, could be tracked. For example, for soil erosion, we had very scattered data and were really unable to capture what the depletion or addition of soils had been over the time period we were looking at. So either in terms of kilometers squared of erosion and land that was made unsuitable for grazing, or some measure of volume of soils loss would be a really useful number to have to track their depletion.
Our group looked at some of the environmental externalities of economic activity, and we divided these into 2 categories. One was pollution, and this is mainly stuff that has a relatively local effect, air, water, and noise pollution, and a second category, which is long-term environmental damage, which is damage from climate change and ozone depletion primarily. And we're going to look at air pollution and ozone or greenhouse gas emissions here. So this was our data for air pollution. We calculated this primarily based on the number of vehicle miles that are traveled, vehicle kilometers that are traveled here in Iceland, and looked at some European studies that had estimated the cost per mile traveled. Because Iceland has lower population density, we took the low end of these estimates at Thorstein's recommendation. We have pretty good data for the last 10 years on vehicle miles traveled. I'm going to keep saying vehicle miles traveled. I studied transportation in the US, and I've said VMT so many times, I've had a hard time switching to kilometers, but bear with me. And farther back, the data gets a little shakier. One thing that's really interesting on this graph is this big spike here in 2006. In addition to looking at pollution from traffic, we were measuring the impact of hydrogen